So we're here at the Corning booth, and what are we looking at here? And hi, so who are you?
Oh, my name is Josh Cobb, and I'm an engineer who developed some of this technology, but this is really showing the Lotus Nxt Glass, which...
So there's just a sheet of glass there?
Nope, this is Gorilla Glass. The Lotus Nxt is in the high-resolution displays made by AUO. That is in here, and that enables, our Lotus Nxt enables very dense pixels, and those dense pixels are about 1,045 pixels per inch. And this is incorporated into an augmented reality demonstration using Gorilla Glass and our design, for the optics that go beneath it.
Nice.
And so actually the side that you look through is through here. I don't know if you can get in to see it, but...
So it's very important to have super high pixel density on this kind of application.
So, right, because that enables you to have a small display which shrinks the size of the system.
It's like a 1080p there, or even more?
Yeah, this is 1920 by 1080, or the displays. And so the Lotus Nxt material is what allows the backplane to be able to have very small pixels on it, less than 25 microns.
This is lower is better?
Yeah, so it's the total pitch variation, the total thickness variation, and also the coefficient of thermal expansion allows you to make very fine features on the backplane.
So my name's Ellen. I'm here at the Corning booth launching the new Corning Astra Glass. The Corning Astra Glass is a backplane TFT glass substrate. Here we have a corner of a television that we've cut in half, and you can see the backplane TFT substrate is this stack of glass right here. These are color filter and TFT backplane substrates, along with the optical stack and the LGP, so this is what the inside of the television looks like if you were to cut the corner off of it.
Corning is glass company, right?
Yes.
And that goes all over the electronics all the time? And why is it so important to have the glass?
So the glass substrate is what actually enables the panel makers to make the TFT that is required for the display that you actually watch. So the Astra Glass is, like I said, a backplane substrate. It's specifically designed for the oxide TFT process. And so we have designed the substrate to do three very specific things in customers' processes. Those three things are: one, it's designed to be very dimensionally stable, which is important because when the customer takes the glass and puts it through their panel making process, they want to make sure that they have low total pitch variation. So if you want to take a look at this plate here, we're showing the difference between low total pitch variation and high total pitch variation. Okay. And so you can see here, these lines are the TFT, and the color, the RGB, are the pixels. And so low total pitch variation glass keeps the alignment very nicely for the panel maker.
This is like enlarged by a million times or something?
Yeah. And this is a high total pitch variation. You can see that the pixels don't align very well with the TFT. So the point is to make sure that when the panel maker puts our glass through their process, that they have good alignment and good...
Oh, sorry. Yeah.
Sorry. Good alignment and good panel economics in their process.
So what does it improve on the TV to have Astra Glass?
So right now what's happening is panel makers are moving from amorphous polysilicon to an oxide TFT process as they're going to higher resolution, faster refresh rate panels. And so the substrate is specifically designed to enable them to move to these really large form factor, high resolution televisions.
So what's the main advantage of going to oxide instead of the amorphous silicon?
So when you're moving from amorphous silicon to a process like oxide TFT, you're required to do so for high resolution, and it's because it increases the electron mobility. It's what allows the panel makers to really increase the resolution to these super high...
Is this an 8K?
This is an 8K.
8K. So this is basically enabling 8K?
This is enabling oxide TFT for 4K and 8K television.
And also better 4K?
And better 4K.
And does it provide better transmission of the luminance, the colors or something, or?
No, it is specifically designed for dimensional stability, for oxide TFT, and lower light leakage. I wouldn't say it's higher transmission relative to ours.
All right. And what do you talk about here?
So here we're showing the difference when you go in pixel, so in resolution, when you go from Full HD to 4K to 8K, and so you can see the crispness and the picture quality as you go from the lower resolution to the higher resolution. And this is what the backplane substrate, the Cornea Astra Glass backplane substrate that we're making enables for panel makers.
Does this go just on TV market or a whole bunch of other stuff?
Televisions, tablets, notebooks, anybody that's using oxide TFT for their panel making process.
Is it going to be on smartphones?
Probably not. We have Lotus Nxt Glass, which is geared specifically for LTPS, which is what is used for smartphones currently.
All right. Thanks a lot.
Sure.
All right. Awesome. Let's go
Claire.
around here.
Yeah.
Hi.
Hi.
Hi. So who are you?
My name's Claire.
And what are you showing here?
Okay, so here today we are demoing this Iris glass,
Can you come close to the mic? Yeah.
okay,
Yeah.
which is glass like I play. And now we have these 3 monitors being commercially available in the market. We have 24-inch and 27-inch here. And glass like I play actually is a material that you use like I play to guide the light through. And the reason that glass is so good is because glass doesn't absorb moisture. And also if you're under this high temperature or high humid environment, glass will not expand. So with this, it can give you a very slim design and
Is this
also
what you talk
narrow
about
bezel.
here? This
Yes.
stuff? So which
this-
one is your tech here?
This is just like we're demo here that we can do this. This is extraction pattern, how we extract lights, and this is the dark size that we're talking about, 200 micron, and we can also make dark size as small as 36 micron. With this, you can have an even brighter set to enable to increase your brightness by 10%.
So it increases the brightness on the PC monitor market? Is that what it does?
We also have some model being launched in the market for TV applications as well.
And so it provides the best PC monitor experience, super thin.
And also brighter set. You
Brighter
also
set.
have a narrow bezel design. As you can see that you also
Yeah.
almost cannot see the border here. So those are the currently available in the market that you can see.
Nice.
And this one also have QD coating on our glass because of the process it requires high temperature. So you
So
can
it's
only
QD
realize-
glass?
QD coating on our glass.
Quantum dot
Yes.
coating.
Yes.
So not QD glass. How's it different?
Because this QD, normally if you're talking about QD display, it's QD film. You have another film to embedded to the,
So the quantum dot is on the glass.
it's coated on the glass.
All right.
Yes.
So I'm George Kellogg. I represent Cornea Precision Glass Solutions, the augmented reality solutions product line, which is high-index glass that serves the augmented and mixed reality marketplace. So what you're looking at here are wafers of high-index glass that are 150 millimeters, 200 millimeters, and 300 millimeters. The first example we're illustrating is that as you go larger in wafers, your economics, your costs for your lenses that go into your AR devices will go down. You get better material utilization. What I'd like to highlight is we have glasses that are greater than 1.7 refractive index. We offer in production today 1.7, 1.8, 1.9 refractive index glasses. Additionally, we have world-class metrology to ensure that we have very tight geometric tolerances, and we have the ability to connect you to our Corning laser technologies for dicing of these from wafers into lenses that will go into your wearable device. We also have an example of a customer's wearable device that has used a Corning design high-index glass to create a wearable augmented reality device.
So why do you do the glass in wafers?
So wafers, because the world of augmented reality, mixed reality customers are leveraging a significant installed base and capability from the semicon industry to automatically handle and process wafers of 6, 8, and 12 inches in size.
So you would do these in like those fabs that do wafers, or how
So
does it work?
it will be a line constructed like a fab. It will not be a semiconductor fab, but it'll be a line that has incoming gray space into a clean area. You'll clean the wafers, and then they do nanolithography, dicing of the wafers, and then post-processing before they're assembled into a wearable.
So this process here is a unique new kind of process?
This process right here is using Corning existing high-speed automated nanoperforation for dicing pieces out of high-index glass.
And what are the things I can see where those shapes?
So these shapes are simulated lens sizes, and they illustrate how many you would be able to achieve out of a small diameter, medium size, and a larger diameter. So you get improved economics because you get much better material utilization out of a larger wafer. And our customers are migrating to larger size wafers for their production process.
Does it do something in terms of the experience of the AR that's unique in the market?
So relative to index, that's where the experience becomes different. You can, if you go from say a 1.5 or 1.6 glass and go to high index, for each tenth of index, you increase the field of view for a like design by 5%. So as you go from 1.7 to 1.8 to 1.9, each gradation will give you 5 degrees of field of view larger, so the experience will be richer for the end user.
So it's kind of like acting like a lens?
It is in fact a lens, but the refractive index glass is really about managing an encoded photon through a waveguide structure and decoding it back to the end user.
You do the waveguide too?
We do not design waveguides.
So
Our
there's a
customers
company
design.
making a waveguide on your glass?
That's correct.
And
they use a high refractive index resin that's matched to the glass, and their proprietary design is processed on the glass through nanolithography.
So it's like not printed on, but somehow added on to the glass.
You might say that there's a process that's called NIL. It's a stamping process that yields the encoding and decoding gratings on the glass. There are other techniques that they can deliver the technology as well. It's not always a surface relief grading. This example is in fact.
So it's very important to use Corning for the AR market.
To deliver high quality imagery for the user and to provide the most convenient and aesthetically pleasing form factor, small form factor, and to deliver basically the crisp contrast and color that you expect. Using Corning high index glass will deliver that experience.
Hi, my name is Corey Moriarty. I work for Corning Gorilla Glass. Today we're showcasing what is called selective surface etching. And this is a technology using our inkjet proprietary technology on the back of the screen print to the Gorilla Glass.
So what was that? What is that?
Oh,
That's
so
the
this
back
is just
of what?
on the back of like the Gorilla Glass. So this is actually just like a puck, but on the front we have an etching called selective surface etching, and this provides a lifelike feel to the texture. So if you want to take a look at it, you can actually see that the etches to the actual image.
So it provides texture somehow?
Yes.
How can you do that?
So using like an AG etching, we're able to simulate the graphic image on the glass itself.
Nice. Do you also simulate wood?
Yep. So we're showing the precisions of how we can do this through the wood, lining with the lines in here.
So that would be kind of like, let's say, on the back of potentially a phone or back of a
Right.
tablet, a laptop, or?
Yeah, so we're working with our customers to see the best use case for the application. These are great for our decoration. We also are seeing different types of use cases, like say for example, for a back of the phone, a laptop, any other type of application that they're looking for. So what's great about this one is it shows how light refracts from it. So as you move it, you can see how the pattern changes as well.
How do you make these?
It's through an etching process.
So you can make huge kilometers of these like quickly, or it takes a long time?
We usually don't comment on the supply chain, but we are able to do a process, and we work with our customers now.
All right. And there's also the backs of these?
Yeah, so what we're introducing today is our Corning Gorilla Glass 6, which was launched last year. And this is a glass which survived 15 consecutive drops onto rough surfaces on average from 1 meter drops.
Nice. So you don't just do the front of the phones, you do the backs?
Yeah, so we actually do both the front and the back application. A lot of customers like to use like a wireless charging capability, along with for 5G networks. It's great for transmission connectivity.